Hopefully you found some of these crazy questions to be a little fun. They definitely are meant to test your showing your work skills, your checking your work skills. They are definitely difficult and there are lots of opportunities for mistakes. So when we go through them, I really want you to kind of listen to how I talk through my process. This is very much what's going on in my brain when I do these kinds of steps. And so that's what checking your work really is. It's this voice in your head that's kind of telling you when you reach these danger zones, negatives, distribution, fractions, things where you know that you are likely to make a mistake, and just giving you that extra little check before you move on to the next thing. And so I'm constantly checking in with myself in my head as I go through math problems, and that's what causes me to fix careless mistakes. It's not that I don't make careless mistakes, it's that I catch them as I'm doing them. Being good at math is not about making 0 errors. It's just about catching all of the errors that you make, and that way you don't lose points for kind of silly reasons. So let's take a look at these. We're really just taking these values and plugging them in. So what is the value of 3 minus 2x minus y when x is negative 1 and y is negative 5? So we're just going to start by plugging in. So 3 minus 2 times negative 1 minus negative 5. And notice how I put those parentheses there, right around my negative 1, my negative 5. That's a good habit to get into. Negatives are easy to lose, so I'm putting extra parentheses to make sure I don't lose anything. I also didn't do any arithmetic when I plugged them in. I literally just took a step to plug them in. That way, then I have to check 2 things. Then I have to check the arithmetic and the plugging in. Here, I just need to check in with myself. Negative 1 is x, negative 5 is y. That's what I plugged in. Now I can start the process of solving. So 3 minus 2 times negative 1 is negative 2. Negative negative 5, 2 negatives become a positive, so that's plus 5. 3 minus negative 2 plus 5 is 3. So 3 minus 3 is 0. There we go. And I check in. Notice I'm not doing anything with the negatives that I don't need to do. I'm doing one step at a time, and I'm kind of checking in with myself before I move on. So there's your answer, 0. Number 2, what is the value of this thing when a is 2 and b is negative 3? So again, let's plug in without actually solving anything. So a is 2. Negative 3 is b, and again, those extra parentheses make a big difference. So a is 2, negative 3 is b. Looks good. Let's start solving. So 2 squared is 4. Now here we got to be careful. Negative 3 squared is positive 9. Okay, so negative 3 squared, and I still have that extra negative. So I'm checking my work. I'm looking to make sure I didn't lose an extra negative there because I sensed danger. That's a possible mistake I could make. So 3 times 4 is 12, minus 9, and then minus 4. So here I can just finish up. 12 minus 9 is 3, minus 4, and that's negative 1. So there we go. It's really about those negatives and how they interact with the exponents that worry me most here, and so that's where I kind of slow down and check myself. All right, number 3. This is a good one. So negative 4 squared over negative 2. Okay, so t is 4 and is negative 2. Everything is substituted where it's supposed to be. However, the key piece here is that, notice, I use those parentheses again. And here it's like, well, why did you need to? Because 4 is not really a scary number, right? There's no negative to be lost. But it really helps me recognize that there's a negative that isn't going to be affected by this exponent. The exponent is on the t. It is not on the negative. The negative is its own thing out there. And so for like PEMDAS reasons, order of operations, that negative is not going to get touched by this exponent. So what really happens here is the negative stays. 4 squared is 16, and now we have negative 16 over negative 2. And that's just a division problem. 2 negatives become a positive. 8, and I double check. I look back and just make sure I've got those negatives right. Negative 16 divided by negative 2 is positive 8, and I'm confident in that answer. So yeah, there's some rules you got to know about how negatives and exponents kind of fit together, and when we square something versus, or when we square a negative versus when we don't. But the key is, if you're in the habit of using parentheses kind of like all the time, then you're more in tune to the changes that can occur that would require you to square something or not. So it's an important habit. It's just good to kind of be aware of the subtle things in an equation. And so this is how we do that. We check our work constantly. Let's look at number 4. So here we've got this negative out here that scares me right away. So I'm going to write that. And then 2, 6 plus negative 3 and 6. Now, one little trick here is we got to make sure we put the right things in the right places. 6 is for Q, negative 3 is for P. But notice that the first letter in the equation is Q, and yet the first letter written there for us is P. So it's very common sometimes we accidentally plug the wrong thing in the wrong place. So I'm just mindful of that, and I'm double checking to make sure. All right, now that negative off to the side, this is going to be a big problem. I can't touch this. This is on the outside of this fraction. I don't want to mess with it until I absolutely have to. So I got to resolve the fraction first. So 2 times 6 is 12. Plus negative 3 is really just a minus 3, so I can just get rid of those parentheses now. And again, the negative stays. It's lingering out there. 12 minus 3 is 9, and 6 is 6. And so what I'm going to do here is I'm going to simplify by breaking these numbers into their prime factors, right? So this is simplifying a fraction. A lot of times you can do this in your head. I'm just always very nervous. Again, we've just done some addition and subtraction, so I don't want to accidentally do 9 minus 6 in my head. I need to do 9 divided by 6, so that means I'm going to cross out a 3 for each, and I'm going to end up with 3 over 2. And I can't forget, I go back, that negative still lingering there, so I'm going to put it here so that I don't forget about it. But that's my answer, negative 3 over 2. So again, negatives are tricky with fractions. I prefer the negative to always be on either the top or the bottom, but it doesn't have to be. That negative can kind of move around, and so I just need to be careful. Generally, you'll see it written on the outside. Personally, when I write fractions, I prefer to put it on the top just so I'm less likely to forget it. But that's a personal choice, and sometimes, you don't really have that option too. All right. Number 5 is a good one. Okay. So we've got to be careful here because a lot of negatives, a lot of parentheses. So let's go slow. Negative. M is negative 1 minus parentheses 3 times negative 1 minus parentheses negative 2 as K. Close that parentheses. Minus 1, close parentheses. So again, M is my first letter in the expression, but K is the first letter given to me, so I just want to make sure. Did I put all the M's in the right places, all the K's? M is negative 1. Yes, I made those substitutions correctly. K is negative 2. Yes, those substitutions are correct. And now I start the hard process of sorting through all of these layers of this question. Remember, we want to work from the inside of parentheses out, when we have arithmetic, at least. So I'm going to go slow. So that negative 1, I can just drop those parentheses around it. It's going to linger as a negative 1. 3 times negative 1 is negative 3. Minus 2 is plus 2. Minus 1. So again, I'm going to check back in. 3 times negative 1 is negative 3. Check. Negative 2 is positive 2. That checks out. Moving on. Negative 1, I'm going to not touch that yet. So again, now I've got parentheses. Let's solve that thing in the middle there. Negative 3 plus 2 is negative 1. So yes, negative 3 plus 2 is the same as 2 minus 3. Yep, negative 1. That checks out. Again, I'm not touching some of these things yet. Negative 1 means that this becomes a positive 1. And now I'm going to drop the parentheses. Right, so I'm subtracting a negative. That's the same as adding a positive. That's 2 negatives becoming a positive. And now I can really start to deal with that stuff inside. Negative 1 plus 1 means that those two terms are going to cancel. Negative 1 plus 1 is 0. And 0 minus 1 is negative 1. And finally, negative of negative 1 is positive 1. And that is the answer. Whew. Now, this might be a case where I actually genuinely do go back to the beginning and kind of look at all my steps again because I'm so nervous. There was just so many opportunities for making a mistake. The sign was switching constantly. There's a lot of ones. It's scary. And so that's a good thing. When you feel that nervousness about math, that's your brain telling you that this is a danger zone. And that doesn't mean you're going to get it wrong. It just means that the odds are higher. And so good. Adjust. Check your work, be more thorough, be more careful, know where you might lose those points, and you're more likely to catch the mistake and not lose them. That's the key. Confusion, nervousness, those are good things if you use that power to your advantage. Now let's look at this other exercise, plugging the values into the equation. So it's very similar, but what we're assuming here is that someone else did the work, you maybe did the work, and you got this solution and you need to check it. So this is a legitimate way of checking algebra solutions on tests is we take the number that we got out of all of our algebra and we put it back in and see. And so in this case, we would just kind of do what we did before. 2 minus 3 times 2 is equal to 8. So 2 minus 6 is equal to 8. 2 minus 6 is negative 4. So no, that doesn't work. Negative 4 and 8 are different numbers. So no, x equals 2 is not a solution. And I'm not going to do this for every single one of these questions, but I just want to show you, why might we spend the time doing this? What is the advantage? Well, if we had done the algebra here, 2 minus 3x equals 8, it's a very common mistake that people make, which is they lose that negative. So if you subtract the 2, I see this all the time. You might not think you're guilty of this, but it sneaks up on you. You just don't know. You feel really confident. You're just moving fast. That negative in front of that 3 gets lost. And then when it does, look what happens. We get that x is equal to 2, right? The same solution that we were prompted with here. So it happens. You don't want to make those kinds of mistakes, but even the best mathematicians do. You're moving fast. You're confident in your ability. Things get lost. A smudge and a negative kind of look very similar. And so this system of taking that result and plugging it back in can save you points. It can catch something that you missed. So it's different from what we were doing in the last exercise because that was more about trying to prevent a mistake from happening. Here is a way of, double checking that it didn't happen. And so plugging those numbers in for x or y or whatever the variable can maybe save points that way. All right, number 2 is x equals negative 6 a solution. So here we just pop it in. And again, I'm going to be very thorough with my negatives. I'm checking back. I'm making sure negative 6 is the number. It's going in for both the x's. It looks good. 4 times negative 6 is negative 24. 1/2 of negative 6 is negative 3. Notice that I'm not doing all of the algebra, all the arithmetic at once. I'm just taking little steps here and there, one little piece at a time. So negative 24 plus 16 is negative 8. And negative 3 minus 5 is negative 8. So yes, this is a solution. That's what should happen when we have a solution that works, is we're going to get like a number is equal to itself. Negative 8 is equal to negative 8, so we're right, versus before, negative 4 is not equal to 8, so we knew we were wrong. So that's what it looks like when we have a valid answer versus a wrong answer. All right, 4, negative 1. Some of you just, without even testing it, are going to say that this is correct, but you're falling for a little trap here. 4 and negative 1 are the solutions in the sense that they are the x-intercepts of the quadratic here. If you don't know what I'm talking about, that's okay. Then you probably got this right because you didn't even think about any of this. But if we plug this in, we're going to see very quickly that it's wrong. So we're supposed to plug 2 numbers in. This is a point. So x is 4 and y is negative 1. If we did that for this equation, we'd have negative 1 is equal to x minus 4, 4 minus 4 times 4 plus 1. So negative 1 is equal to, 4 minus 4 is 0. That's what we expect to happen. 4 plus 1 is 5, but this doesn't make any sense. Negative 1 is equal to 0. It's not. It doesn't work in there, and that's because we're confusing the idea of a solution. Negative 1 is an x value, but the solution is not the same thing. You're confusing an x-intercept with a point. And so this point here needs to be plugged in as a point with an x and a y coordinate. Now, the simpler thing would have been to have done that from the start with the easier equation, and we would have gotten the same result. And so that's no good. So this is not even a point that lies on either of these lines, or either of these functions here. But here we've got the same functions, and we've got the point -2 and 6. So in this case, let's start with the simple one, right? So out of laziness, I would do 6 is equal to 4 minus -2. 6 is equal to, that's 4 plus 2. And so yes, 6 is equal to 6. Looks good. But it's not enough for it to just work in one of these. When we have a system of equations like this, we need the point to work in both of the equations. If it only worked here, it would not be a solution. So let's try it in the top equation. 6 is equal to -2 minus 4 times -2 plus 1. So -2 minus 4 is -6. -2 plus 1 is -1. So two negatives make a positive. 6 is equal to 6. So yes, this is a solution. Now at number 5, the thing that some people make a mistake of is they kind of forget the difference between x and y. So on the first equation here, again, we're just plugging in. So 2 is x and -5 is y. So 6 minus 10 is equal to -4. That is true. So that looks good. Now be careful though, in the second one, notice that they kind of flipped it around, right? They put the y coordinate first, so we just need to be consistent, right? So y is still -5, so we still are plugging in terms of x and y, not in terms of like first and second, right? That's the better way to think of it. So -5 is equal to 2 times 2 is 4. 6, 7. 4 minus 6 is, ooh, see, I made a mistake. I caught myself. There we go. 2 squared is 4 times 2 is 8. 8 minus 6 is 2, and 2 minus 7 is -5. So look at that. Perfect. I didn't plan that, for the record. So there you go. It does work. This is a solution. And it was because I did what I was doing in the first exercise that I was able to catch that mistake. As I was doing the second one, I was looking back and I was noticing that my numbers didn't make sense. 2 squared, or 2 times 2 squared, is what I should have had for that first term, and I forgot the squared and I caught it. So it can happen to anybody. That was a perfect place to end that. So just don't get cocky with math. No matter how good you are, everyone makes mistakes. You just need to catch them, because on standardized tests, you don't get partial credit for doing most of it right. It's either completely right or completely wrong. So in this case, I did a lot of work for number 5 and I was mostly right, but I would have been entirely wrong as far as the score is concerned. So I've put these steps in place to check my work as I go. You should do the same. If you're not confident in math, then this is good for you because it builds that confidence. You're going to see many times you are correct, and you'll also learn a lot about where you go wrong so you can prepare for those moments and actually catch the mistakes as they happen. It's not going to happen on every step, but certain weaknesses that you have, you'll start to notice, and you'll be able to prepare for them and get those points anyway.